Okay, so housekeeping, but thanks to Samir, so I have this ready for your presentation. I am that guy between you and lunch, so I will try to be to the point, and I'm open to questions. I'm going to leave my email. I want to invite you guys to the container tutorial that I'm going to be running with Samir, with Andrew Young from Sandia, and from Shane Cannon from the Lawrence Berkeley National Labs. So it's going to be a full afternoon tutorial, and I think we are going to go deeper than my 20-something minutes talk here. Also, Samir also gave the link. There is a Canopy workshop on Monday, and we are going to be talking about very interesting topics like running Hadoop and Spark and kind of MPI applications or tools like OpenShift, Kubernetes. So it's not just LSF as Slurm, but we are trying to see how can we leverage these new sort of tools on the HPC side. Okay, so I'm here to talk about building high-performance containers on multiple architectures, and I'm very thankful for the invite. So the ORNL team invited me to be here and kind of showcase what we are building with them, because as you guys know, so Summit is power, but they have also like small deployments inside ORNL and also other national labs. So we're from Sylabs, we are thinking on a tool on which developers will only think on their tooling, and then the containers are going to be built for multiple architectures and be available for the developers. And is root-free, so to your question on if the user needs or not need root privilege to building those tools, everything is being designed from the base ground to let users with their accounts handle this. So, as I said, who am I? If you guys have questions after this, feel free to reach. I want to start with some history for things that are happening like this week from the Docker exit. So we are not going to have Docker next year, so like the ecosystem is changing. And it's very interesting how now is IBM, Red Hat, doing the containers in the 2019 now. But everything started from, I would say, Unix v7, and wasn't to the point on which, I always forget, 2008, when the canonical people, the Ubuntu canonical people, came out with the idea of LXC. So I don't know if everyone that knows about containers these days really understand that the concept, a real thing that you can touch with your hands, was the LXC containers from canonical. Before that, it was really like a small implementation, but it was canonical that started all this movement. Then Docker took off and is today under the Red Hat leadership with Podman and all the OCI and the Cloud Native Computing Foundation that the containers are really taking off. So why I like containers and why I am into containers for HPC is because of this. Any developer these days trying to jump into HPC, into research computing, as Samir said, it is getting more and more and more complex by the minute. So data scientist today that is signing up for a university today, this is what he is going to deal with today. I don't know how big this is going to become in 2 or 3 years, right? So containers really come to the rescue to help researchers to deal with all these dependencies, and not just containers are lacking short, are running short on helping. So this is why SPAC is really taking off to help users to deal with this. So this is what a user is doing today in academia. Like you guys are using like TensorFlow for the earthquake research. I can guess that you guys are dealing with a lot of layers of dependencies and complexities right now. So what about containers? I introduced the Podman logo here, aside from the other logos that Samir showed to you. And, wow, sorry for the resolution. It looks better in the laptop. I was not planning on that. They provide a really easy way for researchers to bring their own environment into the production ecosystem, right? So most HPC systems are SUSE or Red Hat, but many developers, researchers, they have their laptops with Ubuntu, right? So we get this complexity from the researcher to the production ecosystem. So the initial thing that you can solve is just helping the researcher take his environment into production without dealing with the system admin dependencies. But someone needs to build that container. So I want to start talking about that we should not give the researchers the responsibility of building the container. This was a practice kind of introduced by Docker some years ago, like let the developer do everything, just helping get into production. I'm really against that, and as the work we are doing with the guys in RNL, we should not give the developer or the researcher the responsibility of building the container. They should be thinking on their MPI application, on the TensorFlow application, and shipping all of that into a system that is going to build the container for them. Using the operating system package manager in a container is not sufficient. So why I'm saying this is because I have become a really good friend with the SPAC team, and I really think and I'm really pushing that although yes, you see a lot of container recipes these days using Jom install, IPT get install, that is pulling pre-built binaries for you. And we in the HPC community should be moving into compiling your binaries inside your container, not just Jom install into your container. That is going to give you a real performance boost. Like I tried with OpenMPI, like the basic OpenMPI, and you build a container with a Joom install OpenMPI, or you compile your OpenMPI with SPAC, and instantly you can get like a 10% performance boost from the Jom to compiling. So that's why I'm saying that. And well, the other line adds to what I'm saying right now. So containers, thanks to Samir, kind of introduced it. What I wanted to say about containers, that they, containers are introducing to HPC and academia a new concept that we didn't have some years ago, and it was the DevOps ecosystem. And this is something that we are working in the ECP project under the Super Container project with Andrew Young. And it's how can, what I'm trying to push here is researchers should be thinking about their application, and the ECP project is going to do the rest for them, right? So this is the DevOps that we are trying to introduce into academia. Not the regular DevOps we see in Uber and Netflix and these companies that they also use DevOps. What we are trying to push in the concept of DevOps in academia is that the developer is going to be thinking in MPI, and then everything is going to be built for that developer in a DevOps platform that is going to be using SPAC, that is going to be using all the tools that are really designed to get the best of your system, right? Because as I was saying at the beginning, every system is different, and now that we have here in the Open Power, if you're building for Power, you need to be thinking on Power. If you're going to be building for x86, you need to be thinking on x86, and that is not yet involved in DevOps. So Samir kind of introduced the rest. There's a performance kind of thinking on the container side, but I think that idea has already been debunked. Like everyone is using containers in HPC and they are seeing the same bare metal performance. So I think this is not yet a topic that we need to talk about. Containers in HPC. So from the ECP project, the Super Containers project, we are really seeing a big adoption of containers among all national labs. and also private universities and private companies doing HPC. So the main thing is the BYOE, Andrew Young trademark. The composability of containers is that you can build a workflow by tidying up different containers one after each other. I really don't like when I see these big container recipes that they install like half of the internet in a single container. We should be really moving into a container is for one binary, for one application. If you want to do composability, then you must have like different containers that talk between each other and not just put everything inside a single container. Containers are portable, but when I say portable, there's a huge caveat. And since we are here in the open power, it's a bigger caveat, right? Because if I build my container in this laptop that is x86, I cannot use it in a power system. Done. So portability is dead. That word is dead there, right? When I say portability, is that if I can share with someone my container recipe for him to build and reproduce, that is going to give me a bit of portability of my application, right? If the other person is following the same OCI, the Open Container Initiative patterns for building an image, he is going to be able to port my container to another system. And version control integration. This is another thing that is not yet in academia. I'm very surprised because Git has like 20 years now from, and researchers do not use Git as much as we want to. And something that we will be pushing from the Super Containers project and the ECP project is that every container built for running in a production system, let's say Summit, Frontier, or whatever, should be created after a Git push, right? We should always be thinking that researchers, no matter MPI, TensorFlow researchers, they should always be communicating with the system admin via Git, right? And this is why I'm introducing the version control integration in this layer, is because I still see people building their containers in the laptop and shipping the container to the system admin. Hey, this is my container for my research piece running, right? And there's no version control happening there. So I think this is the slide that inspires me by being here, and is 2020 looks dark and it will get darker, right?
Lovely story.
We have Power 9, and now this little guy here that I really don't like it. We have like 10,000 different versions of x86, the Knights Landing, the whatever landing, and the AMD different versions of x86. We now have ARM, and this is going to be crazy for researchers in the future, because when I'm in university talking with people, I always tell students, this university has an ARM cluster, but let's say tomorrow you are going to be doing your PhD or an internship in a different university that is using Power. You cannot just take all your binaries and go to the other university and keep running your research. You need to rebuild everything. So it is getting crazy, and it's a pain point for researchers today. This is one single research of a university and everything that they need to be embedding in a single data center to run a researcher's thesis or whatever. So this is why I say that it's worse yet to come. So it's not just the architectural shift, but it's also the application layer. And this is something that we are trying to tackle from the ECP project, and Samir is trying to tackle from the E4S project, because all these layers and dependencies are getting ended in the E4S project, so to help researchers move all these along into a single project. How we're tackling this from Sylabs and the project that we are collaborating with RNL is that we have a remote builder and a container library that really allows a system like Summit to have what I'm saying, DevOps workflow from Git to building your container to storing your container. And what the remote builder and the container library really does is a simple system that we are trying to get ready on ORNL on top of OpenShift. So we will be building the containers for the researchers and storing them in a container library. And this container library stores the containers with two names. The name that the researcher gives to the container, because a lot of researchers just fell in love with their containers and they get like really tied with the name, and they set names like the dog name of the researcher or something like that, but that is not reproducible. The container library also stores the container with the chasm, right? The container library sees a container as a single binary, and it assigns a chasm to that container in a way such that you can track the chasm of your container. If it was changing versions over time, it will give you different chasms of the same container over time, so you can do version control over your container. And so this is a job workflow. The container, then once the container is built and stored in the container library, you can get that container and run it whenever you want. And when I say this, is that the container library also has the feature for architectural tags. So when you store a container in the container library, it would say, this container was built in x86. This container is an ARM container. This is a Power container. And if someone is trying to pull that container from a system that is not the same architecture, it is not going to fail, but it's going to throw a huge warning. This container won't run, or is going to have a big problem running in this system, right? So we are trying to get into that workflow of telling the people this is not the best architecture for this container, and just printing a huge warning. We do not want to fail because people still is doing that, so that's why we are only doing like a huge warning right now. So this slide is really from the super container project, and it's like the overall idea that we are trying to push into the community and how we are trying to help people with the super containers project that is part of the ACP project, and it's how do we want people to think about containers in HPC, right? It's not just taking everything that is working for Uber and Netflix and these huge platforms using containers, but how we as HPC people in academia should be thinking on how to use containers, right? So the first and main thing is we need to come out with a way to allow developers and researchers to test their containers in their laptops, in their workstations, before pushing them. And the topic hasn't come out yet in this morning, but building a container takes energy, takes power, right? And sometimes building a 3D Linux container that Andrew is always talking about it, can take 10 hours, 12 hours, and that is really translated into money, right? So if we allow the developer to test in their laptops, in their workstations, we could be saving money on the test system by just allowing them to test in their laptops. And this is going to be possible via containers. Via containers are going to allow developers to specify how they want to build the container or their application, but just specify. So as I was saying, they will say, I want my container to be built like this, but I'm not building it. From all the things that I've been saying this morning. We need to focus on interoperability, and it's the same. The developer should say how they think the container will run, but everything else is going to be managed via remote builders, DevOps systems, things like OpenShift. Everything is going to be a layer above the researcher. The researcher is not going to be doing the operability of the container. We need to be providing containerized services. This is already happening. In ORNL, they are trying OpenShift. So a lot of universities are already also going into OpenShift or other Kubernetes flavors, right? To help researchers with containers, with container services. And performance matters. And this is a cool thing that I'm going to be talking in the Canopy workshop, is how the PMIX project is also getting into the containers ecosystem and helping to port performance from one system to another by using PMIX. And also the container, by building it in the same architecture of the system, is going to give you almost native performance over moving the container in a runtime way. Oops. Sorry. So container DevOps, we're really working into the DevOps thing from the Super Containers project. We need to allow long batch queues, like building applications like Trilinos in a DevOps way. And the dream is really someone working in the Trilinos library is going to do a git push before going home, and that is going to trigger the build of different containers in the system. And when that researcher came back at the other day, the system is going to tell the researcher, hey, we built 3 or 5 containers for you, and the best way to run your library that you were working yesterday is going to be this one, right? So that's how we say long batch queues, because building some libraries can take hours, and the researcher doesn't want to be waiting for it. Some systems, like, I don't know if Orenel, but in Sandia, they are leveraging GridLab registry services and the GridLab runner to do all of these applications. So it's another way, but not using OpenShift, but using GridLab to trigger a full workflow of, after a git push, build the container, store the container, and maybe test the container for the researcher. So for those that had never seen a DevOps pipeline, this is how it looks. You need to be able to develop, deploy, and test in your laptop, in your workstation, then deploy into production, right? So that's why I say developers need to be able to test in their laptops or workstations before moving the container into the bigger system. Something that is upcoming and that I'm working right now with people from SPAC and people from Red Hat is how to tie out SPAC with the project Build that is now a project from Red Hat, and the project Way, in such a way that is going to be a SPAC and not Singularity, not Docker, not any container runtime, but it's going to be SPAC communicating with Builda to build a container and push it to Quay. Why Quay? Because Quay is being used in the supercomputing project as a registry, the default registry. You can use the Docker registry or whatever registry you prefer, but this is the registry that we are pushing to use. This is an example that I was running last week with the SPAC team, is that you define a SPAC environment, and from that SPAC environment, it is going to build a container, and it is going to store the container in Quay all for you, right? From SPAC. I have it took me. So I want to show you guys one example here. So this is a new capability of SPAC. It's really small here. It's called SPAC environment. It's kind of for the people that already know a Docker file. It's like a Docker file for SPAC, where you specify the packages that you want to build with SPAC, and it is going to build it for you. And then we have a Docker file, and this Docker file, what it's going to be doing is, and this Docker file is in the next version of SPAC. SPAC is going to generate this Docker file for you. Right now it's by hand. This Docker file is doing two things. First is a pre-built, curated version of SPAC that is already stored in the SPAC CentOS repo. It is going to pull that SPAC container. It's going to compile your applications using SPAC, and then by using the Red Hat UBI container image that is a very curated image from the people from Red Hat. It's going to store your binary and it's going to give you the resulting container that is going to be a performant, optimized container, really lightweight container. Because when we are doing this jump from building the container with spec to just building a container with the Red Hat UBI, we are dropping everything, every dependency that we don't need. And then, so here I'm building with Builda, and what it does is that it goes, it takes a spec container and starts compiling the application for me, right? So this is upcoming work, but it's what we are building for the community from the Super Containers project in the ECP project, is how can we tie all these applications together to really facilitate the research workflow for everyone in HPC. And again, thanks for the ORNL people for inviting me. Thank you. Questions?